Hey everybody, today's lesson is R.6 Day 1 Rational Exponent. So if you remember what the word rational means, it means fractional. So right now we're doing, for the very first time, exponents that are fractions. Okay, so I wanted to do a little bit of review first. So these problems up here, I would pause the video and make sure you get them copied down into your notes. I'm going to go briefly through how I solve some of these, but the very top up here, this should all be review stuff. And they keep in mind that all those problems look really similar, but the negative signs on the exponent and on the number kind of throw everything off. So make sure that you get those copied down and you understand thoroughly why those answers are the way they are. One thing I wanted to draw your attention to is this down here. Notice the difference between 3a in parentheses to the -2 and then no parentheses with a -2 exponent. So we have to be really careful with this. See what I circled in red here? When there's no parentheses, the exponent is only on the variable that it is, like, I like to refer to it as touching. Okay, so that 3 in this problem actually stays on the top because it does not have a negative exponent with it. It's just the a that has a negative exponent. So the a drops down to the denominator and then becomes a squared in the denominator, whereas this has parentheses around it. That means that everything goes into the denominator. So big difference on that one. I wanted to briefly touch on that. Keep in mind when you raise a fraction to an exponent, the exponent goes to both the top and the bottom. And then a fraction with a negative exponent means flip it, and then that exponent stays the numerical value, but it changes to positive. And so then again, you take the exponent to both the top and the bottom, and then you simplify if you can. Those fractions do not simplify. So that's all review stuff, and that should be pretty simple for you and nothing too new or different. Pause the video if you're not done copying that down. Otherwise, I want to focus on this example real quick. So there's a couple different things that you could do first, and what I'm noticing about this problem is all these negative exponents here. And so what I'm going to do is take those negative exponents, it's not distributing, but what I'm going to do is raise everything in this parenthesis to the -1, and I'm going to do this parenthesis to the -3, and then this to the -2. And all that means is I'm going to raise everything in there to that negative value. So it's going to become 2 to the -1 and x to the -3. Remember, you multiply exponents when they're on top of each other like that. That's my dog barking because I'm sitting outside. And now I have everything in here raised to the -3, so that's going to be multiplied by 2 to the -3 and x to the -12, and that's all the numerator. Same thing in the denominator, 2 to the -2 and x to the +4. Okay, so now basically what we have to do is move almost everything. The 2 to the -1 is going to go down. These two are both going to flip-flop. I'm just moving everything individually from the top to the bottom to the top. This is going to come down and this is going to come down. So I'm moving all of those negative exponents. So when I do that, keep in mind the x to the 4th is going to stay. That's the only positive exponent, so that's not going anywhere. So I'm just going to rewrite those and then I'll simplify in another step. So the 2 to the -1 came down here, the x to the -3 came down here, and the 2 to the -3 came down here, and the x to the -12 came down here. And what else do I have? That x to the 4th. So I'm kind of lining everything up and organizing it and getting rid of all the negative exponents. And what did I have in the denominator that came up to the top? The 2 squared. Okay, now we have some cleaning up to do. 2 squared is 4. The numerator was simple enough. How many 2's do I have in the bottom? This one and this one. So there's 4 of them, so 2 to the 4th, which is 16. Maybe I'll write 16 instead. And yeah, that 4 over 16 is going to reduce. Now let's count the x's. 3 of them and 12 of them makes 15, and 4 of them makes 19. So x to the 19th. Last thing to do is reduce the 4 over 16. And I know that the 4 goes away, so make sure that you don't lose your fraction though. That means that the 4 and the 16 reduce to 1 over 4, so you do need that 4, or you do need that 1 in the numerator so that your answer remains a fraction. Okay, so lots of negative exponent work, but just wanted to kind of touch on what to do when there are so many variables and so many exponents. There's multiple ways to do that problem. Kind of just pick somewhere and go with it and see what happens. Simplify as much as you can. Alright, so now we're getting into the fraction exponents, you guys. This is a big deal. So what we're going to talk about first is the very first easy thing that you know how to do already. 2 squared. That means 4. And how about this side? 3 to the third, that's 3 times 3 times 3? 27. So what we're going to do now is introduce a fraction exponent. Okay, I'm actually going to do the 27 one first, because did you know a fraction exponent, here is the huge, really awesome definition of fraction exponents, it actually turns it into a radical. So this becomes the cubed root of 27, which is 3. Okay, so did you know that every radical was actually a fraction exponent? So I like to use the example of learning a new language. A lot of you might be in Spanish or German or Chinese or any other kind of language that you're learning. And you know, for example, in Spanish, hello and hola mean the same thing. They both mean hi, but they look and sound totally different. But the important thing is that they mean the same exact thing. You guys, that's the same kind of concept that's going on with a fraction exponent and a radical. They're in 2 different languages, but they mean the same exact thing. And what you have to be able to do kind of in your head is take a rational exponent, which is a fraction exponent, turn it into a radical, and then simplify it. So let's talk about what this one would be. 4 to the 1/2. What that means is square root of 4. And so did you know that there's actually an imaginary 2 hanging out in front of a square root? Because what do you think the square actually means? The difference between a square root and a cube root. You don't actually write the 2, but just know that it's there. It's kind of imaginary. It's like when you have when you don't have an exponent on a number, you know there's an imaginary 1 there just hanging out. And so this is the same exact thing. Actually, a 1/2 exponent means square root. And so what we're going to do here is just square root the 4 and get 2. Okay, so bouncing back over to this one, I'm going to turn this into a radical again. That means the cube root of negative 27. So what you're thinking to yourself is what times what times what gives you negative 27. And you are allowed to cube root negative numbers, you guys, because negative 3 times negative 3 times negative 3 is negative 27. So negative numbers are allowed to be cube rooted. Okay, so now let's do the same thing with the negative 4 over here. Can I square root negative 4? Okay, so you're thinking to yourself, what times itself gives you negative 4? And there's no possible way to do that. So this is actually a non-real or imaginary answer. And that is all you have to do. We will learn second semester actually how to simplify imaginary numbers like that, but for right now I think in Math Excel it's going to be a click box and you can either simplify it or one of the options is non-real solution or something like that. So just keep in mind that you cannot square root negative numbers. Okay, so that is what a fraction exponent is and what it does. Let's actually take a look at some of these because they're kind of tricky. But once you get the hang of it, it should be pretty simple. So keep in mind what a fraction exponent means. And you might not have to actually rewrite this the way that I do, but while I'm getting used to it, I'm going to actually write it in a radical. I know that that 1/2 exponent means square root, and I know square root of 9 is 3. Okay, in this one, I cannot square root a negative number. This is non-real. And if you wanted to, like if you didn't recognize it right away, then since that negative sign is in the parentheses, put negative 169 inside the radical because that's what 1/2 exponents mean. And that's a non-real answer. So you need to start kind of recognizing that. What about 8 to the 1/3? So the 1/3 makes it a cube root, and that answer is 2. Okay, and then what about this one, a 1/4? We haven't talked about that yet. Well, it's the same thing, it's just a 4th root. So you're thinking, what times itself 4 times gives you 16? That happens to be 2. 2 times 2 times 2 times 2 is 16. And then last one over here, negative number 64 to the 1/3. Make sure that the 64 is the only thing that goes in the square root. The negative just kind of stays in your answer. So I'm going to put my cube root of 64. And you might have to think about this one for a second, but 4 times 4 times 4 is 64. And just notice that when the answer has a negative out in front of the entire thing, no parentheses, your answer will always be negative. So that's one kind of rule of thumb that I like to live by. Okay, let's do a couple more. 8 to the 2/3. So here's where it gets crazy. And what you have to think about here is top, in, bottom, out, front. I like to think about top in, bottom out. And so what that means is the top number goes inside of the square root or cube root or whatever root it is, and the bottom number goes out front. So I'm going to put my 8 inside a radical, and then I have to figure out what number goes where. So the top, this 2, goes on the inside. So I'm going to put that here. The bottom number, the 3, goes on the outside. And this is really strange, and this is very different from stuff that you've done before. So what I've done is I've taken this thing that's in a foreign language and I've translated it a little bit into something that I might be able to handle now. So what I like to do is that translation first and then see if I can simplify the radical. I like to get it back into the radical language because I think better in radicals. Okay, so from here, what I like to do is make the number smaller first. I like to do the cube root of 8, which is 2, and then raise it to the second power, which is 4. So simplify the radical part first and then keep the exponent and do that part afterwards, so you end up with 4. Okay, this next one is a negative exponent, so remember what that means. That means 1 over 25 to the 1/2. And you know what a 1/2 exponent is. It's a square root. So that means we have 1 over 5. So look at the difference. This negative exponent made a huge difference that made us have to put that square root of 25 in the denominator. Okay, if any of you were thinking non-real, that would be if the negative sign was in front of the 25, because that would mean we would have a negative in here. So just be careful of that, maybe if that's something you were thinking about. All right, how about this one? I'm going to turn it into a radical again. I'm going to put the 49 inside a radical, and the top number of the fraction goes inside. So I put my 3 there. And the bottom number of the fraction, the 2, goes on the outside. So that's just a normal square root. I'm not going to write the 2, but know that that's where the 2 goes. So what I'm going to do first is the radical. Square root of 49 is 7. And then keep the 3 as an exponent. Well, this is kind of a hard one, but 7 times 7 times 7 is actually 343. And we kind of use the same numbers over and over again, so you will get the hang of simplifying some of these. Now we've got another one, negative 125 to the 2/3. And then keep in mind that this negative sign is out front. That just means that my answer is going to be negative. So I'm going to have negative, and then I have my 125 inside a radical. I'm keeping the negative sign out front. The 2, the top number goes inside. The bottom number goes on the outside, or out front, if you will. And what I'm going to do first is simplify the cube root of 125. And I'm going to keep my negative sign too. So negative. The cube root of 125 is 5, and this exponent is still 2. So keep the negative. You're not squaring the negative because there are no parentheses here, so be very careful about that. 5 squared is 25. And again, my rule of thumb, if the negative is not within parentheses, then your answer will be negative. Okay, how about doing this fraction? This one's a little bit weird. Remember, when you have an exponent on a fraction, that turns the fraction in, or the exponent on the numerator and the denominator. And so you know what that means is the cube root of 64, since we just learned what that new language is. Cube root of 64, cube root of 125. Well, the cube root of 64, that's 4 times 4 times 4. And 125 is 5 times 5 times 5. There's our simplified fraction. All right, so just a couple more problems that I'd like to talk about now. These 4 down here, and then we are going to save these last 2 to do in class just in case you have any questions. So let's talk about this one. And what I want you to think about is, A, don't be freaked out by the fraction exponents. They are just normal exponents, they're just not whole numbers. Okay, so remember how to do a problem that looks like this. X squared times x to the 4th. Remember how you keep the x and then you add the exponents, so you get x to the 6th? So that is all we're doing, you guys. What you're going to do is you're not going to multiply the 6's together. We don't multiply the x's together. All we do is we deal with the exponents. So I'm going to keep the 6, and I'm going to take these 2 exponents, and I am going to add them together. So 4/3 plus 1/3. That's all you're doing. It's the same exact thing, except there's a number instead of a variable, and the exponents are fractions and not whole numbers. Big deal. So we're going to keep the 6 and we end up with 5/3 exclamation point. Okay, so should we change this into a radical? My answer to that would be if the question starts with radicals, then leave your answer as a radical now that you know both languages. But this question is in rational exponent language, so your answer should stay in rational exponent language. Okay, same thing we're going to do here. Keep the 3/3 and add the exponents, 4/3. That gives me 3 to the 6/3. And yeah, 6/3 reduces, so 3 squared. And yeah, we know what 3 squared is, 9. Boom. Next question. Okay, what we're going to do here, same exact thing. Keep the 2, add your exponents. And one of them just happens to be negative, no big deal. We're going to make it 2 to the, that would be -2/5, which means 1/2 to the +2/5. And I'm not changing any of these back into radicals just because all these problems started with rational exponents, so you want to keep rational exponents in your answer. Keep in mind it's not simplified if you have a negative exponent, so we don't want any negative exponents in our answer. So that's why I changed it, dropped it down. Okay? Now we just have one more. So this one's very similar. We're going to keep the 2, but remember what to do with the exponents when you divide. You subtract them. Okay, so what I'm going to do is 4/3 minus 2/3, and that gives me 2 to the 2/3. Okay? That was a crash course on rational exponents, you guys. Bring your questions tomorrow. Like I said, what we're going to do tomorrow in class is we're going to go over these 2, and then we're going to do a lot of group work in a worksheet together, okay? So, I'll see you tomorrow.